So there's my 13. Subtract 4 from both sides. That's going to give me negative 3y equals 9. When I solve that, I get y equals 3. Y equals negative 3. And there's my solution. X equals 2. Y equals negative 3. So 2, negative 3 is the solution. Solve a nonlinear system here, so I just can't add them up. So what I'm going to do is I'm going to solve this for y. I'm going to subtract x from both sides, and that's going to give me y equals 4 minus x. Now I'm going to take that quantity and plug it in wherever I see a y. So x squared plus, and notice y equals 4 minus x equals 6. I didn't need to wrap that because there's a plus sign, but I could have just as well put parentheses around it. Now I'm going to bring everything over to the left, so that's going to give me x squared minus x, and then 4 minus 6 is negative 2. And I'm going to factor this, and the factors of x squared are x and x. The factors of 2 are 2 and 1. Notice 2 is larger than 1, so that's going to get that negative sign there, and then it can't be negative because negative 2 times negative 1 does not equal negative 2, so the 1 has to be positive. By zero product property, that's going to give me an x value of 2, and another x value of negative 1. Those are the x values in a coordinate where these two shapes intersect. The line hits a parabola. So now I need to find those y values. And we just solved for y up here, so we know that y equals 4 minus x. And we have to figure out what x is. Y equals 4 minus x. And if we look, we notice that x equals 2. So I'm just going to replace that x with the 2. And 4 minus 2 is 2. Y equals 2. I'm going to replace that x with the negative 1. 4 minus minus 1 is 5. So there is where that line intersects with that parabola. Number 43, is the same concept. I have y equals a line and a sideways parabola. That parabola actually goes that way. And this line goes through it and cuts through it. It's probably going to hit it in 2 spots if we were to graph it. But we're just going to solve it. So I'm going to take the x equals 3 minus y squared. And we can see from the solved equation that y equals x minus 1. I just plug that in. Now I have to FOIL that out. So it's going to give me x equals 3 minus, FOIL out is x squared minus 2x plus 1. Distribute the negative, so x equals 3 minus x squared plus 2x minus 1. I just distributed the negative across the quantity. Now I'm going to combine my terms and simplify. I'm going to bring the x squared over to this side, so I have to deal with a positive x squared. I'm going to bring the negative 2x, or positive 2x over, so I'm going to minus 2x. X minus 2x is negative x. And then 3 minus 1 is 2, but when I bring that over, it's going to be negative 2 if I do the arithmetic. And if we notice, it's the same as that equation. So we already have the x values when we factor it. The x value is going to be 2. The other x value is going to be negative 1. And we need to determine what the y value is. This time, our equation is y equals x minus 1. Y equals x minus 1. And we will just plug in our x value. In this case, our x value is 2. I plug that 2 in there. 2 minus 1 is 1. So that's an intersection point. I plug in the x value of negative 1, and negative 1 minus 1 is negative 2. And that is the intersection for that line and that parabola. 44 is a graphical problem, so I'm going to set up an x and y axis. And what I'm going to do now is plot these points. So 5, I have 57. 5, I have 57. So there's 40, 50, 60. Whoops. My scales are off. That's 60. That's 70 there. That's 80, and that's 90 there. Sorry. So I have 57, so that's going to be 60 there. 57 will be a little bit less than that. At 10, I have 74. So there's 70, there's 80, there's 75. So 74 will be a little bit below that. At 15, I have 85. So that's 80, and 85 is right in the middle between 80 and 90. And then at 20, I have 84. So it goes down a little bit. It goes down a little bit. And that slope there, I think it goes down 1 over 5. At 25, we have 61, so there's 60. 61 is going to be that spot just above the 60. And at 30, we have 43. So it sort of looks like parabolic upside down. So we have 43, and we're going to connect the dots to get a graph. And what part B asks us is, where is the slope the steepest? Now, that means either steep going up or steep going down, the greatest rate of change. So they're looking for the absolute value slope. That's going to be called average rate of change. So for the first slope, it's pretty steep. I'm going to find that from 10 to 5. So I just do this little AROP formula with x minus x, or 10 minus 5. And then the value at 10 is 74, minus the value at 5, which is 57. Do a little arithmetic, 74 minus 57. And that's going to be 17 over 5. And that slope is going to be 3.4. So I'm just going to make a little note that this slope here is 3.4. Now I want to find the slope between 10 and 15. So using the average rate of change formula, it's going to be x minus x, 15 minus 10, and y minus y, so 85 minus 74. And that's going to give me a slope of 11 over 5. And that's 2.2. So just in this part, I can tell that 3.4 is steeper than 2.2. The rate changed most rapidly. It doesn't say from positive or negative, it just says most rapidly. This slope, I think we go down 1 over 5, so that's going to be 0.2. Now this slope looks pretty steep, so that's going to be 25 minus 20 on the bottom. The x's, average rate of change, 25 minus 20. And then at 25, the value is 61. Minus, at 20, the value is 84. Notice it's going to be a negative slope. 61 minus 84. That's going to give me negative 23 over 5. And that gives me a slope of negative 4.6. Much steeper than 3.4. And then my last slope, I'm going to use the average rate of change formula again. That's going to be 30 minus 25. And then the value at 30 is 43. Again, it's going to be a negative slope, minus 61. Notice this value is located corresponds to that x value. So 43 minus 61 is going to give me negative 18 over 5. And we'll see what that is as a decimal. Negative 3.6. So the rate changed most rapidly. The interval where the rate changed most rapidly was from 20 to 25. And how did the rate change? It was a slope equal negative 4.6, or decreased. It went down by 4.6 miles per second. Slowed by 4.6 miles per second. I might have to put the word mile there. Number 45, center and radius of a circle. The center is going to be at the opposite of these. So the opposite of that is negative 2. The opposite of that is 3. The radius is going to equal the square root of that number, or just 3. So that's the center and the radius. This one, they want me to complete the square. There's a shortcut for it. The shortcut to find the center would be just take that value and half it. Well, what's half of negative 4? Negative 2. But remember, it's going to be the opposite of that value. So that's going to be positive 2. Take that value and half it. Half of positive 2 is 1, but it would be negative 1. Now, to find the radius, we're going to complete the square. So let's see, x squared minus 4x equals 4. And I have to complete the square on the y values. Y squared plus 2y. And I'm going to throw these values when I complete the square over here on the right side and make this a sort of strange looking system. So half of negative 4 is negative 2. And then I square that negative 2, and that gives me a plus 4 up here to complete the square. And when I add 4 to this side, I add 4 to the right side. That 4 is from adding 4 over to the right side prior. Half of 2 is 1, and then I square that 1. And that 1 squared is going to give me a 1. When I add the 1 here, I have to add it over on the other side. And now this is going to quite rapidly give me the vertex form. This is going to be x minus 2 squared plus y plus 1 squared equals, and it equals this here tally of 9. So my radius is going to equal the square root of 9, or 3. Make a sign chart for 47. Let's see what they actually want me to do. So first I want to make a number line and find out where the zeros are for number 47. So there's a 0 at 2. Because it's greater than or equal to 2, it gets a closed circle. At negative 1, again, it's a closed circle because it's greater than or equal to. And then at 4. Now I know where I'm supposed to shade, so I'm going to find out what values when I plug in are greater than or equal to 0. This is a nice problem to use the calculator on and use the table function. So first I'm going to make a number line and find out where the zeros are for number 47. So there's a 0 at 2. Because it's greater than or equal to 2, it gets a closed circle. At negative 1, again, it's a closed circle because it's greater than or equal to. And then at 4. Now I know where I'm supposed to shade, so I'm going to find out what values when I plug in are greater than or equal to 0. This is a nice problem to use the calculator on and use the table function. Y equals, and clear out that last equation. And I'm going to type in the equation that we were given, which is parentheses. Once I have it typed in, I'm just going to hit graph. But we can set the window. A 10 by 10 window will work for this problem. So I'm just going to hit graph, and it's going to graph that function. And basically, I want to know where it's greater than or equal to 0. It touches and turns at positive 2, sort of. There's kind of a strange thing going on there. No, it touches and turns at negative 1. So I'm going to take this information and use it to do the interval notation. So is the graph greater than 0 to the left of negative 1? And the answer to that is yes, it's greater than or equal to 0 to the left of negative 1. So to the left of negative 1, it is greater than or equal to 0. The signs are positive. Then at 1, it's greater than or equal to 0, so it's true there. And between 1 and 2, notice the values are still positive. They're up there in the air. So it's positive between 1 and 2. Now at 2, it goes through. It is equal to 0. It goes through. But just past 2, between 2 and 4, it is no longer positive. So that's no, it doesn't work. And then once I get to 4, it goes above the graph again, and it works at 4. It's greater than or equal to 0, and it's positive. So if I were to shade this graph and make a number line graph out of it, it would look like this. And the arrows would be pointing out. So in interval notation for number 47, whoops, negative infinity does not get a bracket. It gets a parentheses. And it's going to start at negative infinity and go all the way to 2. Union, and then pick up at 4. And then go all the way to positive infinity. And that's the interval notation. For 48, I'm going to bring everything over. And it'll be x squared minus x minus 12 equals 0. I'll factor it. So that's going to be 3 and 4. So x and 4, x and 3. Whoops. X and 3. 4 is bigger than 3, so it gets that negative. And then in order for this to be negative, that has to be positive. And it's actually not equal to 0, it's less than 0. So the values on my number line in this case, for 48, are going to be negative 3 and positive 4, or something happens. But because there's no line underneath the inequality, at negative 3, it's going to be an open circle. It's not allowed to equal negative 3. It doesn't touch negative 3 because there's no line under it. And at 4, there's another open circle. And then we're going to take values to the left of negative 3 and throw them in and see if they're negative. So if we throw in negative 4, Let's see if that works. If I throw a negative 4, that's going to give me negative 4 minus 4, which is negative 8, times negative 4 plus 3, which is negative 1. And that's going to give me a positive answer, and a positive number is not less than 0. So no, it does not work to the left of negative 3. Now, if I go ahead and I plug in a value between negative 3 and 4, we usually pick 0. It's the most convenient. That's going to give me negative 12 if I throw in a 0 there. If I throw in a 0 there. So negative 12 is less than 0. So that's a true statement between negative 3 and 4. Now I have to plug in a 5. I can plug in a 6. I can plug in a 7. But I'm going to plug in a 5. If I plug 5 in there, that's going to give me 5 minus 4, which is 1, times 5 plus 3, which is 8. But when I multiply them, that gives me a positive 8. Is 8 less than 0? No, it's not true. So it doesn't work at this section either. So now to graph this, it doesn't ask you to graph it, but I use it to help us. It only works between negative 3 and 4. So the interval notation is going to start at negative 3, but not include negative 3. That's why I put a parenthesis. If that were a closed circle, it would be a bracket. And it ends at 4, and it's going to be a parenthesis again. Find any intercepts, x and y. I'm going to factor it to find the x-intercepts. What multiplies to equal 2? It's going to be 2 and 1. 2 is bigger, it gets the plus sign, so it's going to have to be minus. So there's going to be an intercept at negative 2, 0, another intercept at 1, 0, and y-intercept when x equals 0. So I let x equals 0, I put a 0 there and a 0 there, at 0, negative 2. So these are the x, and these are the y. Number 50, it's a cubic. I'm going to leave that squared and just set this equal to 0. So x cubed minus 4x equals 0. So I'm going to factor out an x, and it's going to give me x times x minus 2. I'm sorry, x squared minus 4 equals 0. X times x plus 2, x minus 2 equals 0. So there's a 0 at 0, 0. There's a 0 at negative 2, 0. There's a 0 at 2, 0. Those are my x-intercepts. Y-intercept, that's where y equals 0. That's where x equals 0, I'm sorry. That's where x equals 0. So when x equals 0, I plug a 0 into there and there. The y-intercept is going to be at 0, 0. Notice it's the same as the one above it. 0, 0 is x and y-intercept simultaneously. Number 51, they want me to do the inverse function. So inverse for 51. I like these. I'm going to rewrite it as y equals the square root of 10 minus 3x. Flip-flop the x and y, so it's going to give me a new equation of x equals the square root of 10 minus 3x. Inverse operation, square root of 3y. I'm supposed to solve it for y now. Square both sides, that's x squared equals 10 minus 3y. Subtract 10, so it's going to give me x squared minus 10 equals negative 3y. Divide both sides by negative 3. And my inverse is going to be f inverse of x equals that. And I'm going to get rid of this over here to make it look more fancy. Maybe I have to limit the domain on this. The domain would be x has to be greater than or equal to. I don't know. I think I'm allowed to get. No, I think I have to limit the domain. I think I have to limit the domain on 51. So I take the guts. 10 minus 3x has to be greater than or equal to 0. So 10 is greater than or equal to 3x. That's going to give me 10 thirds. Is greater than or equal to x. So for this particular problem, in order for the inverse to work, x has to be less than or equal to 10 thirds. For the original function. For the inverse function, the range would be less than or equal to 10 thirds, but the domain, I'd have to find the range of this. The range of this would be from 0. Y is greater than or equal to 0. So when you find the domain for the inverse, it's going to be the range. So I'm going to say this domain has to be y is greater than or equal to 0. Or if you did interval notation, you would do 0 to infinity, like that. Little tricky, because the inverse is not a function when you square both sides. X squared is not a one-to-one function. 52. Well, this one looks kind of challenging. I'm just going to flip-flop the x and y if I let that equal y. So that's x equals 4y minus 1 over 2y plus 3. Multiplies both sides by the bottom, so that's going to give me 2xy plus 3x equals 4y minus 1. And I could go one of two ways. I'm going to bring the 4y over and the 3x over there to give me a new equation of 2xy minus 4y equals negative 1 minus 3x. You can factor out the y. And then I would divide both sides by the 2x minus 4. And there's my f inverse. This one you don't have to limit the domain. 53, I believe that's e to the x cubed, e to the x cubed